Okay, so now let's practice together using the graphing exercise.
This example is from Oxford IB Chemistry textbook. We need to draw a suitable graph using the data provided in this table. The question is not included in this page, but we already know this is the observance versus concentration graph. So we can label the graph as graph of observance versus the concentration. After we done this, we are going to label the x and y axis. So we know that x-axis is the concentration. So we are going to label the x-axis as the concentration, and the unit is mole per decimeter cube. Y-axis is your observance, so we can label it as A. Once you've done this, you are going to look at the data, and you're going to see possible spacing of the graph. Okay, so observance is from 0.1, 0.2, 0.3, 0.5, 0.6, 0.8. So we can say this is starting from 0 and 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, and 9. So 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1. For the concentration, same thing, it is spaced out as 0.1, 0.2, another 0.2, 0.4, 0.5, 0.6. So we are going to say it is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. We know the concentrations that's given is the x values, and observance that are given here are the y values. Okay, so we're going to plot these numbers into this graph. The first coordinate point is the 0.1, 0.02, and 0.13. Okay, so I'm going to say 0.1 approximately here, 0.002 is approximately here, right? And 0.13, so I should say it's around this point here. Okay, this is going to be your first coordinate point. Second point is the 0.2 and 0.27. So I'm going to go from 0.2, 0.27, so it will be approximately going to locate over here. Third coordinate point is 0.2819, 0.38. So I'm going to say the 0.28 is around here. 3.8 is around this point. Same thing with the 4 and 0.54. And 5 with the 6.8. And 6 with the 8. Once you've done this, since we are not sure of the uncertainty, we are just going to connect from this point over here to this point. Try your best to have a best fit line. And make sure you're not connecting the line with the origin because we don't have anything starting from the origin, right? So we don't have to connect the line to the 0.
Let's work on this IB question together. This question represents the expectation of the IB.
This is the IB question from the May 2019. So let's read the question first. In a laboratory, experiment solutions of the potassium iodide and hydrogen peroxide were mixed and the volume of the oxygen generated was recorded. The volume was adjusted to the 0 at time equals 0. Okay, so volume was adjusted. Okay, remember this part. And plot a graph of the axis below and then from it determine the average speed of the formation of oxygen gas in centimeter cube oxygen gas. So we know that the volume was actually adjusted to 0 at time equals 0, right? So on top of these data values from this table, we know that our first point should start from the 0 point. We now have to plot these data into this graph paper provided. So the first one is 100, second one is 300, right? And third one is at 500, and the last one is at 700. And when we have 100 seconds, the volume of the oxygen gas provided is, or produced is 2.5. So I will put 100 and 2.5. The point is right here. 300, when time is at 300 seconds, we have 6.5. So we will go to 6.5 right here. Third, when we are at 500 seconds, we produced about 11. So we will go over here. At 700 seconds, we produced about 15. So we have to go all the way to top. Okay. So once you've done this, you have to connect these points, right? So I'm going to connect these points best as I can. Okay. So for these questions, 1 point goes to correctly plotted points. So 1 point is for the correctly plotted points. And another 1 point goes to best fit line. And extended through the to the origin. And another point goes to the average speed of the reaction. Okay, so now we need to identify the average speed of the reaction. To calculate the average speed of the reaction, we have to use the slope to find it. Okay, so slope is equal to delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. So for this case, I'm going to use the 2 points from this table, which are 100, 2.5 and 300, 6.5. Okay, so our x value is time, so that's the reason why I'm using time as my x value, right? And the y value is volume of the oxygen gas. So for this reason, I can calculate the average speed of reaction using the slope equation, which is delta y over delta x, which is again equal to 6.5 minus 2.5 over 300 minus 100 and is equal to 0.020.